Hi, everybody. Welcome to the version 3 introduction for VAST Data. Appreciate everybody spending the time with us this morning, and let's get on with the show. So, for those of you that don't know me, I'm Jeff Denworth, VP of Products. I've been with VAST since 2016, and I'm accompanied by two colleagues today, well, actually three, Howard Marks, our technologist extraordinary, Andy Pernsteiner, field CTO, and Lauren, who runs marketing operations. And we'll get at it. Okay, so today we wanted to cover basically three things. We wanted to go through the latest news from the company. If you've been living under a rock for the last couple of weeks, you wouldn't have known about our news. But hopefully, we won't take too much time talking about this for those of you that have heard. Then we'll talk about, the title of this webinar is 3 More Things to Love About VAST Data. We've got 3 critical capabilities that we're introducing into the platform as of version 3, and then we'll do a quick overview of a few of our highlights from the other 20 additional features that we're adding over the course of this spring. So with that, let's get into the company update. For those of you that missed it, we were kind of fortunate to have received an additional $100 million of investment from a new funding round that was driven by a new investor, which is Next 47. They are an investment arm of Siemens. This came at a pretty crazy time with all of the work from home stuff going on right now. And one of the interesting things about this investment is we haven't even touched our last funding round, our Series B funding round, which is another $40 million. So if you've met some of the people from VAST, you'll know that we spend our money quite conservatively. And what we've done with this most recent investment is basically carved out a very clear path to break even and independence. And so we're going to be around for a long time. We did some calculations the other day, and even if we didn't sell anything, I think for the next 7 years, we would still be able to keep the lights on and keep everybody employed. And since we made that calculation, we've gotten some additional sales. So, so this is our path to independence, and we've been fortunate to have the support of some of the best venture capitalists as well as strategic investors in the market. And of note, one of the new investors that we welcomed in this last round is NVIDIA by way of their Mellanox acquisition. So that's pretty exciting. And the other consideration is that we managed to hit unicorn status throughout this event. Value of the company is now $1.2 billion. This is basically driven by the success and the adoption that we had last year. And what we determined is it's the fastest time to unicorn status of any storage company in history. So it's a pretty special designation. Okay, so so some of the key company updates and highlights. We have now 150 people in the company, about 110 in our R&D team. We continue to place the principal amount of our investments into the product, so that customers can just get something that works and that they love. We are going global. We've been selling across 4 continents, and so things are going well. We've got plans to hire about another 100 people over the next 12 months. And as part of this announcement, we also had some new customers emerge. On the customer side, we had the CIO of Health and Human Services. So this is actually, if you've been tracking the COVID news, this is Dr. Fauci's CIO. He presides over a lot of different agencies in the US government. The 2 in particular that are very much in the news right now are the CDC and National Institute of Health. The NIH has bought a many petabyte system from us as one of the different departments that have bought from us to power a very large computing environment. And what we're doing is we're helping the various agencies that we work with within HHS to move beyond the hard drive era. SquarePoint Capital also came in. I didn't include their quote here for purposes of brevity, but they've been a great customer partner of ours. And then NVIDIA, we're working with them to start to move beyond the kind of shadow AI movement that you find within various kind of large organizations where data science teams will start to bring on infrastructure, and it's kind of outside of the purview of the classic enterprise support teams. And so having a system that's just fast, affordable, and easy to deploy helps companies like NVIDIA take their mission much more broadly. So we're partnered with them on that. Okay, so from a capability perspective, we've been spending a lot of time talking with customers about the versions of VAST that have come out and that will come out. We took the covers off of version 3 just a few days ago. And essentially the way that we think about the product is what we have been selling up until now, even though we've managed to sell a lot of infrastructure, about 100 petabytes in total. What we think of the product up until now has been kind of a minimally viable product. And that was what we were selling throughout 2019. As we turn the corner to 2020, what we are doing is expanding our total addressable market by adding more and more enterprise capabilities to the platform, some of which we'll talk about today, some of which we'll talk about later in the year. And then as we think about what we're going to do next year in 2021, this is when we kind of turn our attentions back to really core innovation. We get to move beyond checkbox features and add a lot of intelligence into the platform such that the system is much smarter about how it's being operated with. B, it starts to answer questions about the nature of the data that's being stored in it that maybe customers don't even ask. So there's a lot that we've got planned, and as the company grows, the size of our R&D team grows, and we can do cooler and cooler things. But today we're here to talk about version 3. So probably the hallmark feature of this release is the introduction of SMB. SMB is obviously the interface that you use to connect up Windows and Mac systems into scale-out storage infrastructure. We've not had SMB until now. We made the decision very early on not to do things like integrate open source Samba stack and just put it onto our platform for a variety of reasons relating to enterprise interoperability, permissions management, performance. And so we took the time and we did the hard work, and we built from the ground up our own SMB stack that we believe that will carry us forward for a very long time. We're calling it resilient SMB for a reason that we didn't entirely appreciate when we started this effort. And as we started to kind of learn more and more about how customers were kind of the SMB experiences that they had with different storage technologies, we started to understand that we built something that's pretty special. Okay, so the key highlights of this release is that it's all done in-house. So we control the code base, we control the performance experience, we control all of the ACL management. We are announcing support for SMB version 2.1 to start, which we think gets us pretty broad applicability into a lot of the markets that we're operating in or entering into. So for example, we have hedge funds that need this for example, MATLAB support. We have large life sciences centers that need SMB support to receive data off of instruments. But this is really kind of the launch pad for our foray into the media market. We've been fortunate to have a lot of animation studios buy our product up until now. And the introduction of SMB will essentially take us to a place where we can start to power editing workflows, transcoding workflows. And the nice thing about VAST is that all of this becomes kind of the easy button for environments to start to build all of their pipeline onto one storage product. And using our pooling capability, you'll see us talking a lot about being able to allocate quality of service for some of these competing workloads that up until now, customers would have had to put on independent storage systems and manage data around their data center. From a performance perspective, we have not yet added things like multi-stream or RDMA support. So we're basically topping out the limits of TCP. From a single client, you can get to 1 gigabyte a second of random writes. On the read side, if you do random reads, you can get to 2 gigabytes a second of performance per client. And of course, what we've built is an exabyte scale out architecture. So in total, you should be able to take that to unlimited levels of capability to support all of the different applications that you will want to build on top of this, this platform. Okay, so on the topic of things that we didn't initially realize that were different, we just basically started talking with a bunch of customers about all of the different considerations that they had when thinking about deploying a SMB infrastructure from VAST. And here, what we realized is that most of the conversation really related around, once people talked about, the different kind of protocol and ACL requirements that they have, the conversation pretty quickly devolved into a discussion around failure management. And through this, we understood that, despite, the resilience claims that a lot of the enterprise storage systems in the marketplace today bring forward, the reality is that as you operationalize high-scale SMB infrastructure in your data center, when something fails, systems will have a really difficult time managing client failover, and ultimately clients end up becoming disconnected because unlike NFS, SMB is a stateful protocol where all sorts of different client information relating to clients that are mounting the system, locks on files and leases, all of that's kept typically in DRAM in a file server controller. And because you don't want to mirror this data across all of the machines, A, for performance purposes, and B, for cost purposes, what ends up happening is that when a machine that's a client is mounted to goes out to lunch, what happens is that client gets disconnected. And going out to lunch could be everything from an actual failure to just an upgrade. And so a lot of the customer conversations that we had really just revolved around how does VAST implement a system that can support upgrades across petabytes of infrastructure and preserve a really good SMB user experience. And nobody assumed that we could just fail over client connections. And they brought to the discussion their experiences with products like Isilon. And this is a customer quote that I pulled off of Slack this morning. And it basically said, once you buy a really big system, you could take days to do upgrades. And it's just hard to guide users on when SMB connections fail. And so, so we didn't really understand why this was such a big problem until we started to look at competing products. And the reason for that is that, whereas VAST can provide support for stateful applications, such as SMB, the implementation of our storage system, and in particular, the logic of our storage, is entirely stateless, which means that all of the file servers that we have don't maintain or own any of the session state whatsoever. The session state is held in 3D Crosspoint as metadata attributes that are distributed across a global collection of Crosspoint devices, which are basically NVMe endpoints that all of the VAST file servers have instantaneous access to. And so the great thing about this is that when you have a file server fail, it doesn't necessarily, or maybe when you're doing an upgrade operation, you can very easily move not just the clients, but also the state of those clients to any other machine instantaneously. So all of the state fails over in microseconds. You have kind of client retries that happen. The virtual IP address will be moved to another machine. And within a few milliseconds, what you have is the client mounting another machine with all of its state entirely preserved. So, so we've actually had some really great beta testers, and I ended up talking with one the other day, and he was just complaining the whole time about how he couldn't get our implementation of SMB to fail by triggering various failover events. And what this means for customers is that upgrades are just simple, and uptime is much, much better than what customers' experiences have been up until now. So this is something that we were surprised about when we realized what we've done, and we're now kind of particularly proud of. And it's all kind of part of the advantage of the architecture. Now, one of the other considerations is around our support for multi-protocol. And just as with our protocols where we've written everything in-house, we've also written our own distributed exabyte scale namespace that we call the element store. And the element store is not a file system, nor is it an object store. It's basically a superset of both of these that kind of defies classic distinction. So when you store, let's say, a POSIX file into the system, it will be assigned both NFS and SMB attributes, and it will also be assigned S3 attributes, such that if you ever want to go read that data through any other protocol, that data is already there. So we started to think about this user management experience with respect to how people manage things like ACLs. And what we realize is that what you have here is a storage system that can allow you to project data through a number of different views. And so our field CTO team has been working a lot with both customers as well as our engineering team to make sure that the permissions management experience can be really elegant and really seamless. And with that, I'd like Andy to just talk a little bit about the implementation of vast views, maybe also kind of a larger explanation of that.
Hi, everybody. Thanks, Jeff. So with all this in mind, our goal was to both give users the flexibility to be able to have a multi-protocol system where they could allow different groups of users to have different control over how their permissions were managed. But we also wanted to make it simple so that people weren't confused about how the system was set up. And so what we've done is we've created a unified view, which effectively allows you to decide at any file system point, a directory, a subdirectory, what the permissions model will be in such a way that it's easy for administrators to comprehend and understand how things are set up. And this, there's a lot of customability to it, but within each one of these flavors that we've created, we give customers the ability to say whether they want a particular group of data to be managed using NTFS permissions or POSIX permissions. There's also the option to manage for both. However, when we spoke with most customers, what we found is that even though they have the ability to manage permissions using both protocols at the same time on the same data, we found that for the most part, they want to steer towards one direction or another. A couple good use cases would be in the genomics space, where you'll have a sequencer, which typically will write data over the SMB protocol. However, primarily what will happen is the data is processed using a farm of NFS-connected high-performance compute nodes, which are expecting to see POSIX attributes. And so in those cases, you would typically want to manage permissions using the POSIX flavor. However, there might be other workflows in the same cluster where customers may want to manage the permissions using the NTFS model, whereby they have users at workstations, either researchers or operations staff, who need to manage various project schedules and that sort of thing. And they want to ensure that even though the data is accessible over NFS, they want to make sure that the permissions are managed using a protocol that they understand and can easily comprehend how things are set up. When we set out to do this, our main goal was simplicity, and then our secondary goal was to ensure customization. So, as we start to push out to more and more customers and receive their feedback, I think we'll center around simplicity is probably going to be the main theme that we chase after here. Now, there are some additional elements within these flavors that allow for different models of permissions management. However, again, we're focused on simplicity to make sure that customers don't have to make complex decisions. I will say that when we compare with other vendors in our space, what we've done is we've made it so that an administrator, when they're looking at this view, they can see at a very simple glance how each of their file system points are configured so that they don't have to go hunting and pecking through a user interface to figure out how permissions are managed. It's all in one place, and it's very easy for them to understand how things are set up. And as the slide mentions, we're storing a superset of ACLs. On the underlying element store, whenever a file is written, we actually translate the inbound ACL request into a superset of ACLs. And then when another file system protocol attempts to access that data, we present it based on what the file system is expecting. However, when you look at the underlying file system and all the access calls that are issued to it, in every case, if a customer comes in over one protocol, let's say SMB, and then later on they come in over NFS, they will receive the same permissions regardless of which protocol they came over, and regardless of what they can see. So most of the work that we've done is to make sure that we have a unified experience so that you don't have any confusion or mismatch between protocols in terms of what you can do. However, in terms of the flavors, the goal there is to allow people to manage permissions using one flavor or the other to simplify things. I hope that covers it, Jeff.
You nailed it. Thank you, Andy. Sorry for flipping the slide on you earlier. Okay, great. So let's move on to the next big feature. You know, we have a number of different names for this capability within the company. Sometimes we call it cloud backup. Sometimes we call it snap to object. And essentially here, what we're offering as of version 3 is the ability to essentially back up your VAST system to another S3 endpoint using our snapshot capability. And so here you'll have a variety of options. If you want to go down the path of building an all-flash backup and recovery target, you can of course use a VAST system. We'll have support for third-party on-premises S3 endpoints as well. These are products such as Minio and Cloudian. And then, of course, you know, we'll also have support for backing up to the cloud. Examples include AWS or Azure. And so here you'll have a lot of different choice for customers that don't want a secondary copy in a second data center. They've kind of moved to a single data center model and they use the cloud for DR. You can absolutely use that. If you want to cost optimize your backup target and or maybe kind of leverage investments that you've already made in hard drive based storage, something like an on-premises hard drive based object store might be a good example of what you can do. Okay, so the capabilities of our snap to object, first it's Delta snapshot based, so there is no performance impact in taking snapshots with VAST, and we just simply will periodically send deltas of the system, often in large S3 objects that we ship to this S3 endpoint. Everything is shipped over HTTPS, so whether that's on premises or over the cloud, it's secure in flight. And we compress the data before it's shipped off such that we use not only the WAN efficiently, but we also make good use of your S3 storage investments. And so, you know, the kind of classic cases you can have both rapid recovery of data that's in a snapshot folder, as well as fine granularity of recovery. And you can set variable retention periods. So you can have the snapshots in your local VAST store be a smaller amount of time than you, for example, would snapshot to the cloud. And so here you have some choice. If your VAST system is live, then you'll be able to see all of the snapshots that you retain. And the other consideration is, well, what happens if you don't have a VAST system to recover through? We'll add another capability that we call the reader. And here the reader is essentially a lightweight utility that can present all of your data that's stored in S3 as snapshots as live directories or live S3 buckets. And basically the reader establishes a read-only mount point that presents all of that data through NFS, SMB, and S3. And so, for example, if you just need to go get a couple files and you want to do that from the cloud, it's very easy. You just deploy a reader and you can do that. If you want to do parallel recovery of a lot of data, you can parallelize or deploy a number of readers to go and kind of pull data out of S3 in parallel. So that speeds up operations. Okay. The next capability is one that revolves around security. So this is our introduction of at-rest encryption. Here we've introduced a AES 256 level of encryption for all data at rest, both stored in Crosspoint in the system, as well as in QLC Flash. It is a system-wide approach to encryption, so we're not yet offering anything like directory level or file level granularity. Within the system, to start, we will have that manage the keys itself, and we'll have support for about 10,000 keys that are pseudo-randomly distributed across the system. Now, the nice thing about the VAST architecture as compared to legacy storage is that here, with our disaggregated and shared everything approach, what you have is the ability to kind of arbitrarily scale up the number of CPUs in your system so that you can extract the maximum amount of performance from your SSDs. And in the case of enabling encryption, there is a slight performance hit, but it's really simple to just go add another VAST server, and at that point, you've not compromised on any of the encryption overhead with respect to your flash investment. So this is the first time that you can start to enable all sorts of different features and capabilities within your storage system and not worrying about sacrificing the performance of what you bought at the drive level that would otherwise be locked behind a controller or some sort of shared nothing CPU that owns a certain number of disks within a system. So our disaggregated and shared everything architecture allows us to combine really high levels of security without performance loss here. Okay, so let's kind of turn to some of the other big bucket features that we have. Version 3 is an incremental kind of rolling series of launches. And we also wanted to cover a few of the things that we didn't announce through February and March that we are now shipping, and we just didn't get into any sort of big company announcements. So if we look at what came out just previously, we've added support for up to 1,000 snapshots. We now have support for OpenStack environments that can consume file services via Manila. We've added prefetch to our read paths so that streaming reads are much faster. We've done that for a lot of our media customers in particular. You now have N-way file locking. I think we had a customer the other day go to a few 100,000 locks on a single directory, which was kind of cool to watch. And support for VLAN tags. Now, next week, we will go live with version 3.0. The big bucket release feature here is obviously SMB. We will also add support for rapid deletion of data with a capability that we call a trash folder. Essentially, as opposed to sitting around and letting your clients wait to chew through hundreds of thousands or millions of files that it might be trying to delete, and this is done kind of in a serial process with NFS, you can move that off to a different part of the system that we call the trash folder, and in the background, that data will all be purged from the system, and you don't have to wait for the operation to complete. And then we add an update to our data reduction capabilities here, and this is one of many that we will kind of be rolling out through this year. So we'll continue to keep optimizing customers' data. We'll talk about that a little bit in a moment. And yeah, then we look at our June release, which is just so close to our announcement that we kind of rolled everything 3.0 and 3.2 into one version 3 announcement. And so June is when we start shipping AES 256 encryption. We add the snap to object capability that we discussed. One of the other features that we're adding is support for SPDK, which stands for Storage Performance Developers Kit. And so essentially, you can think of SPDK as NVMe over Fabric's CPU bypass, or I should say kernel bypass. And in this case, by pulling all of the system calls out of the kernel, we've observed between a 30 to 40% reduction in latency, which roughly equates to about anywhere between a 50% to 100% improvement in system IOPS for reads, for writes, for metadata operations across the board. This is enabling just a level of snappiness and an IOPS improvement that we didn't have before. So this is one of those features where you're just going to turn on the system after, well, I should say it's always on, but once you've completed your upgrade, you'll just find that it's much more responsive. We have some large customers that are now starting to deploy our system at rack scale. And so we've added basically rack or enclosure failure to the architecture such that you can drop whole racks and you'll still be online. And then we have a number of customers that are now deploying our systems into dark sites where we can't get any telemetry. It's a little bit more difficult to get things like any of the logs or statistics that we're looking for. So we've instrumented the system with a lot more capabilities such that our engineers don't have to run commands on your console. When we're trying to do advanced triage, this data will all just kind of be returned by the system in advance. So these are kind of the big bucket features. One of the other things that we have been talking about is kind of a state of the union of vast similarity-based data reduction. So here we've brought to market what we think is a game-changing level of efficiency, and we're starting to see evidence of this capability across a lot of different types of use cases. You know, for example, in life sciences, we see on average around 2-to-1 data reduction. For Splunk deployments, we see 3.5 to 4-to-1 data reduction. We find in certain HPC use cases like weather modeling or seismic processing, you can see around 2.5-to-1 to 3-to-1 data reduction. Probably my favorite story is with one of our animation customers that said they put a directory in a scale-out NAS system that comes from one of our competitors, and the capacity of that system shrank by 10% because the compression had an inverse effect with respect to data reduction. In our case, they saw about 3-to-1. So that's a 66% savings when competing technologies would actually take away capacity when they turn their compression on. And then we have time series databases that we work with in the financial services community. This is, for example, is products like KX or KDB Plus. And we've got customers now indicating to us they've seen as much as 8-to-1 data reduction on their data sets. So this is a quick update from what we were seeing in the field. You know, we'll probably talk a little bit more about backups the next time we get together. And this kind of is kind of keeping consistent our thesis that VAST has the best data reduction in the business, and further emboldens us to support the guarantee that we made that, you know, no other system will find opportunities for efficiency in the way that we will, and we're guaranteeing that by offering to pay for any additional capacity that another vendor would show if we can't meet their numbers, which we have yet to see. So, okay, these are quick updates from the field, and with that, I say that's pretty much all we've got to cover today. There's 2 other questions here that we didn't get to. Yeah, the question is, what's the added value to replace a Pure system for a capacity that I think means 6 petabytes? Why should we consider using VAST? The use case is databases and image processing. So, so we don't consider ourselves a direct competitor to Pure's flash array in all cases. The primary reason is we don't make a block storage target, whereas Pure's flash array does. We have had customers move to VAST from Pure flash array for reasons that their applications could support either file or block. And in the case that I'm thinking of, this is a customer that is running containers. So they were running a large distributed database on top of containers and found that with our product, you saw about 3 times better performance using our NFS over RDMA capability. And as I mentioned earlier, we have a scale-out architecture, which Pure doesn't, with flash array on top of it. data reduction that is unparalleled in the market. So typically we see a cost point that's between 1/5 to 1/10 of what Pure would charge per gigabyte, and a scalability model that is pretty spectacular. So, so yeah, that would be the reason, but it definitely is an application dependent statement that I'm making. And as I mentioned, we don't make a block storage system. So applies in a lot of cases, but certainly not all. And the second question is, will we be sharing the presentation later? We will host this video online, so you can go and reference it whenever you want. We'll send out a follow-on email after the conclusion of this session. Okay. And the last question is, how good is your system with CEF OpenStack latency issues? How do you handle CEF advantages? Not quite sure actually what that means. So if somebody could just clarify what CEF means in this regard, I can give a go at answering it, or if Howard or Andy, you know the answer to that, then feel free to chime in. Okay, next question. What about multi-site global namespace across 2 or more vast instances? Philippe, I'll tell you, you have to wait and see on that one. And then the last question here is, what is the storage density per rack unit before data reduction? And so if you are a density optimized environment and you need very few vast servers, a single enclosure today supports 675 terabytes of raw flash in 2U. So that's about 340 terabytes of raw flash in 1U. And you can multiply that by 40U, and there you go. And did I get them? 4U supports how many drives and capacity, please? Okay, so 4U would support 2 of our storage enclosures, which would get you to 88 15.36 terabyte QLC drives. So that gets you to just around 1.3 petabytes of raw flash capacity in 4U of space. And then question from Alan is, how far out is NFS version 4? And the answer is, in geologic terms, not that far. In terms of when we'll bring an NFS version 4 compatible server out to market, I would say that this is very much on our roadmap, but I won't make any disclosures about that for a little time. Happy to reach out to a salesperson or to VAST, and we can discuss your version 4 requirements more. Did I get all the questions? Still don't know how to answer the CEF question on OpenStack. If it's if the question is around Ceph, like CEPH, the distributed storage system, we don't do benchmarking against them. We typically don't see that product in the marketplace where we're operating much. What we can say is that we can deliver sub-millisecond latency access for both reads and writes and metadata operations across our cluster. So if that's a relevant metric to you, then there you go. And that looks to be about it. Great. Well, with that, I will close the session unless anybody else has any more questions. Thanks for all the questions. This has definitely been the most lively of the sessions that we've done so far. We will be hosting a few more webinars in the coming weeks. We have one that we're putting together with the team that does BioIT World. Because BioIT World, the virtual event, was canceled, they'll be doing a Trends from the Trenches session where we'll be talking a little bit about our involvement in various bioinformatics environments. We'll have a number of other webinars coming up, one about AI, as well as one about our offering for media. So stay tuned. We've got more content coming. And if you have any questions, you can just reach out to hello@vastdata.com. Otherwise, thanks for your time. We'll send an email after this with the content, so you can feel free to reference it back if you have any questions. Thank you so much.